Hey everybody, my name's Daniel. I'm the CEO of Rootstock Labs, joined by Sergio, Chief Scientist at Rootstock Labs, Ramon, one of our research engineers, and Martin, one of the research engineers at Fairgate. Awesome to have you here. We wanted to bring everyone together to have a quick conversation to bring the world up to speed on what happened yesterday, what happened today, and what's coming next for BitVMX and the frontiers of disputable computation. So welcome, guys. Nice to see you all.
Hi.
Hi.
Hi, Daniel.
All right, cool. We're just going to have an easy conversation here. So first thing is, let's do a little bit of backstory. So on the 9th of October 2023, the BitVM white paper was launched, and shortly after it spread like wildfire through the research team here at Rootstock Labs. Sergio, when were you, do you think you were reading it in around November?
Yeah, I think that I took the first version of the paper right away, and I was super excited because this guy Robin, he came with this fascinating trick of basically creating stateful information that could flow between transactions using Lamport signatures, and that allows so many things that when somebody has been studying Bitcoin for so long, and then somebody comes from a completely an outsider comes from with an idea that nobody saw before, then you get a lot of excitement, and everyone started to think about, well, what can we build with this, right? And obviously the first version of the paper was very limited, but then a lot of people started trying to improve it.
In January, I was in Gibraltar, and I remember sitting with Javier, our head of research at Rootstock Labs, and I said to him, what's one of the biggest, most impactful things that's going to happen in our space this year? And he said without a beat, without a pause, he said BitVM. He said, have you read the white paper? I said, no, I haven't. And he said, okay. And he explained very, very quickly what it was and why it mattered. And I said, yeah, but how does that help Rootstock? And he said, I remember this now. He said, we can build a better bridge to Bitcoin with this. As many people will know, the Rootstock Bitcoin bridge is the PoW peg. So the proof of work peg that essentially allows you to lock Bitcoin on the Bitcoin network and unlock RBTC in Rootstock. And while the PoW peg has been up and running for six and a half years, we're kind of restless to always find alternative ways to build better bridges to Bitcoin. So when I heard that was my kind of entry into the journey. And I was like, okay, interesting. And I guess between January and March, lots of conversations happened with Sergio, with Martin's company, Fairgate Labs, and a number of contributors across the Rootstock ecosystem. And then relatively quickly, I remember actually a phone call from a mountain pass in France with Sergio about how important it was to get this up and running. And, we fast forward to the 2nd of April, we publicly announced our plans with BitVMX, the partnership between Rootstock Labs and Fairgate, and what we were going to try and achieve in the next 18 months. I think maybe before we dive further, though, it might be quite helpful, given that we're going to be talking to a very broad audience here, to get some terms right. So firstly, to set the stage for BitVM and BitVMX and what we're trying to achieve here as our other teams across the Bitcoin L2 space, Sergio, what are the limits of Bitcoin today?
Well, Bitcoin has a very limited scripting language that is considered not Turing complete, which means that you cannot take an arbitrary program, those that you program with Java, Basic, C++, any Rust, or any of these languages, and just run it on Bitcoin. In a sense, it's not like the Rootstock EVM or the Ethereum EVM that you can compile a program to these platforms and run it, right? So it's very restricted. It has no persistent state, or at least before BitVM, it didn't have a way to persist state over time, over different transactions, and the resources to execute were very, very limited, right? And well, this is what changed with BitVM.
And so this is what's encouraging lots of teams to look for, let's call them sort of simple and complex paths to expand the functionality of Bitcoin, maybe without disrupting the Bitcoin main chain too much. Within this world, there is the concept of disputable computation. Maybe Martin, can you help us understand what is disputable computation and why does it matter? Apart from being difficult to say.
maybe it's difficult to say. I mean, basically, what it allows is for any two parties, let's say, to run some program defined by two parties that agree on the program to be run. And even though it cannot be run fully on Bitcoin, every of the steps of any of the steps of the running program can be challenged online on Bitcoin. And that brings a lot of new possibilities to Bitcoin.
Such as?
Well, basically, currently any transaction needs to be signed or needs to have a very small script to be unlocked the transaction and move funds from a place to another. And with this, what is possible is to actually make a transaction based on the result of a program execution, and that is completely new to Bitcoin itself.
Amazing.
Yeah. To add a little bit on that, we all know about Lightning Network, and the Lightning Network is basically a network that is built on a very, very simple smart contract that runs on Bitcoin, right? It's a two-party contract that allows these two parties to move funds between them very quickly, right? And a lot of problems on the Lightning Network, for instance, are related to the simplicity of this program. But if we can make this payment channel much more free of new functionality, then we can even expand the Lightning Network. So all the things that have been built on Bitcoin have been constrained by the restrictions on the program. So anything that has been built, you can rethink and try to see how this new possibility can improve that.
And so what then, Sergio, is a SNARK, and why is it important in this development?
A SNARK basically brings two new possibilities. First, it brings what is called proof of computational integrity in a succinct way. Like you run a very big computation off-chain or offline by a certain party, and that party can bring together a proof, often also called a certificate, that of authenticity of this computation. And so by having a very small message, and by small I mean 300 bytes, and that can be verified in 10 milliseconds, you can actually verify thousands of computing hours, right? Theoretically. So the possibilities are really incredible for blockchain technology, where running things on the blockchain is so expensive. The other thing that brings is what is called the zero knowledge property, which basically means that you can hide some part of the input of these programs because they have private information, something related to your sovereign identity, private certificates, anything you want to hide. You can this computation can also hide that. So these are the two possibilities that it brings, particularly in the projects we are working now. We are much more focused on the reduction of the size of the input. Like how do we create a long computation and smash it and shrink it into a very small thing that we can verify very quickly on Bitcoin.
Very cool. And then lastly, Ramon, help us understand, within this, what is BitVM?
So BitVM would be kind of the joint part of a virtual machine that executes an arbitrary RISC-V program and issues a trace, and the protocol that can verify this trace on-chain.
So and why does that matter? What does that unlock?
That makes it possible to create much more expressive smart contracts than the ones that we had until now, because the computations that we can verify are arbitrary. So as long as it compiles to an L file, we can verify it with BitVM.
Okay, so then on the 2nd of April 2024, we announced our plans for BitVMX, and we published the BitVMX white paper on a month later, on the 1st of May. And I think, Martin, you were heavily involved, along with Sergio and others, in writing the BitVMX white paper. Maybe you could just, perhaps Martin first, perhaps give us just an overview of what is BitVMX and how does it differ from BitVM?
Okay, so I think I have several differences. Maybe one of the main differences is how, two parts. One is around the BitVM, it was supposed to verify logic gates, and for creating a program, we should have to construct it like several thousand millions or more logic gates to emulate a program itself. BitVMX goes like a higher level in one sense, that instead of verifying a logic gate, we are verifying a whole RISC-V instruction, and that shrinks a lot of the size of what needs to be verified. And in other part is how, and I think is really important, is how the memory itself is verified or controlled. The BitVM one paper pointed to doing a Merkle tree of each at each step of execution, there was a Merkle tree of the whole memory of the system. And the cool idea of BitVMX is that you don't need to do that. We are just creating just one hash over time, and then we go back and can check also when the last time the piece of memory was modified. And this allows us to create a second binary search to find out the part of the memory that was modified. Maybe Sergio. Yeah.
Well, there's very interesting new design space. Like there are many, teams that are kind of competing in this race to that we've been first, right? To bring SNARK proving into Bitcoin. But there is really a very interesting design space. So what we have focused is on having a simple protocol, because simplicity brings security. Complex protocols tend to have a lot of security problems, that we wanted to have a protocol that is simple and cheap. And for this is very important for this, because one of the main Rootstock use cases is financial inclusion, like bringing real users from the real world into this new economy. And we thought that, a protocol, a bridge that, potentially only a few participants that have hundreds of thousands of dollars can control, then that would be against, the ethos of Rootstock. So we wanted to create a technology that would really allow to create cheap. It would be cheap for operators to participate in this in a bridge, right?
So this is at the high level what we've tried to achieve. This is what BitVM is, BitVMX is. We've kind of put some dates down, launched at the beginning of April, BitVMX white paper at the beginning of May. We're now in late July. So we've been on this journey as a group now for 4 months. Ramon, what have you been building? What have you been working on for the last 4 months? Tell us a little bit about the protocol and tell us a bit about the work you've been engaged in for the last 4 months.
So in the last 4 months, I started writing the white paper, and where all the protocol is described. And once we published in early April, I just jumped into the first implementation of the protocol that allows two parties to execute an arbitrary program and just challenge it on chain. And all this journey finished yesterday with the publication of a dispute on chain in testnet.
Okay, tell us a little bit about what you were doing yesterday then. Tell us about what getting this dispute published on testnet actually took and what we have achieved as a milestone.
So we took an arbitrary program, we compiled it, and more precisely, we compiled an SNARK verifier, and two parties that were separated, they executed this SNARK program, each one in one computer. And just by communicating through the testnet Bitcoin network, they have been able to agree on which one of the parties was wrong on the execution.
Got it. And this is live. This was published yesterday on the Bitcoin testnet, and we tweeted this out. So then, what happened today?
So today we have been able to successfully execute the same challenge in mainnet.
What we're going to do, I'm going to share with you now the testnet dispute, which took place yesterday. Here it is. Happened around in the afternoon yesterday. And if we spin all the way down to the bottom. So Ramon, what are we looking at here?
So here we are seeing at the beginning the decodification of the input encoded with winter needs, followed by the verification of a RISC-V instruction on chain.
Okay, very cool. And if I jump over here, we can see this is the mainnet transaction, and this was confirmed only 13 minutes ago. Sergio, here it is. Here's your work.
Cool. Great, guys.
It happened. It's real. All right, fantastic. Now, I understand that in many ways we've managed to publish a particular type of challenge, but this opens the door for different types of challenges to be published in different types of technology. Is that right? So this is we've followed a particular route, but there are different routes we can. Is my understanding correct?
Yeah. So for the protocol to be finished, we need to implement the missing challenges, but in the technical video that we released yesterday, we are already showing that we are able to detect them. So it's just a matter of short time to have all the other challenges finished and the protocol fully working.
Well, look, congratulations to everybody that was involved. I think some furious Slack message writing and some late nights and some. What's your choice of stimulant? Are you a kind of Red Bull and Diet Coke guy, or is it peanuts and bananas, Ramon? What's your go-to?
Or Diet Coke.
Diet Coke. How about you, Martin? What is your go-to? Oh shit, I need to keep working. Mate, of course.
Mate, of course. Yeah,
of course,
all day,
obviously. Okay, very cool. So let's look forward then. So this is now published on the Bitcoin main chain. Super exciting, but we've got big plans. So what are we doing next, Sergio?
Well, this is a turning point on the whole project that we envisioned 4 months ago. So at this point, we are ready to start designing. We have already started designing a new Rootstock bridge, and this involves several parts. It's like designing the directed acyclic graph, which is called the Covenants transactions that will support these the multi-party BitVMX protocol to execute bridge and to evaluate bridge payouts. Okay, but we also need to create what is called a like client, which is a function that validates Rootstock proof of work, and this is the function that is going to be compiled into RISC-0. Then a SNARK will be produced, then a SNARK will be produced, and then the SNARK will be verified on BitVMX. So this is a pipeline of stages that we are testing that involves new components. One of the components is the RSK like client, and the other component is this multi-party implementation of the BitVM protocol, right? Because until now we just work with 2 parties, but now we want to open this to any number of operators and verifiers. And this is very important because the POPEG is probably the most secure bridge ever created, but from the point of view of being permissionless or being open, it's a set of parties, we know them, but it's not easy, to join, right, anonymously, right? But with a BitVMX based bridge, we are able to allow anyone to participate in the security without compromising the security of the other participants. It just adds more security, more participants, just add more verifiers, more security. So that's something that is great, really.
So Ramon and Martin, as research engineers, you guys are going to be hands-on with this problem over the next couple of weeks and months. What are you looking at next specifically? What are the things you're going to be working on to try and make BitVMX fully published, fully working, and fully live, and then using it for a Rootstock bridge?
So first of all, implement the missing challenges that we hope to have as soon as possible, and then open source the code so everybody can profit from our work, so we can share with the community all the work that we've been doing.
Love it. How about you, Martin?
Yeah, I think that wrapping up the CPU for being published is like the first next steps, and we are very close, I think, to be able to do that. Next, of course, is to complete the rest of the missing pieces to have the whole protocol on set up. Also, in a simpler way, today the CPU is really easy to use. You have like several commands that you can run a program, emulate it, verify it in a Bitcoin emulator locally. You can debug that. It's really amazing and easy to use. And we hope to have similar tools for the rest of the protocol, right? I mean, that you can set up the transaction, look at for the transaction on the net. The whole thing working for everyone to use. Yeah.
I want to add to that there are many very interesting challenges on optimizing BitVMX. Just to mention one that we have a solution, we think we have a great solution, is called the chess clock problem, which is basically for the whole dispute, every participant is given some time. But since every step on this challenge response protocol requires to wait for the participant, then we have to give the participant a lot of time for that. But then these all time slots add up, and then the full dispute can take long. So one of the ways to solve it is thinking about the chess clock idea, where you give a participant a whole amount of time, and he's able to split it and use it as he wishes, but he cannot take the whole time for every single move, for every single transaction. And this is an open problem, and we think we have a solution for that. And that is key to reduce the security bonds and make this much more efficient. And similar to that problem, we have many other problems that we think we can solve better. So I'm expecting news about research during the next 6 months about not only building things, but improving constantly from the theoretical point of view what we are building.
Okay, love it. So there's a whole pipeline of different technologies that are going to be brought to bear on this. SNARK, Starks, disputable computation, risk zero. This is an upgrade to the original BitVM proposal. We're going to be using it to build a better bridge to Bitcoin. While the power peg is strong, it's robust, it's the most performant Bitcoin bridge in existence today. We're not stopping. We want to innovate further. We think there's a better way to do this. Now, there are other teams engaged in this challenge, right? We saw that the team at Bitcoin OS also published something similar yesterday. Sergio, is that the same as what we've done, or is it different, and how does it differ?
Well, it's a completely different design and obviously completely different code base. They aim only to verifying snarks, which is kind of a restricted way of implementing it. We are general purpose, like we obviously showed how to verify snarks, but we can verify much smaller programs or any kind of problem. So it really makes us our solution much more flexible to implement other kinds of protocols, not only the ones that are based on stars. And of course, as I think it was Martin that mentioned, if in the future there is a new Stark mechanism, a new SNARK mechanism, whatever, we can implement very directly, where the other solutions, they need to rebuild everything almost from scratch, because they are actually embedding the SNARK verifier into the scripts, right? The Bitcoin scripts. So I think we have an advantage on that. But we still have, there is other projects that are, trying to optimize other parameters. For instance, the BitVM2 projects, they are trying to optimize the number of rounds. So they think that they want to have a protocol with a single round, and they are going for that, even if that makes the protocol much more expensive. So I think that each team is also trying to optimize different variables.
I mean, it's one of the exciting things for me is we know from public claims that, I can't remember wrong, the StarkNet team, I believe the Stacks team, the BitLayer team, possibly the Build on Bitcoin team are also engaged in efforts here as well. And the reason this is really exciting is not only does it bring more engineering time, more capital, more focus on what is quite a significant problem for Bitcoin, but it also gives me a lot of faith that someone's going to crack this problem. This is going to get done, and it's going to get done in a relatively short period of time. And I hope it's the Rootstock Labs Fairgate team that do it. Okay, very cool. Thanks so much, guys. This has been great. Roman and Martin, nice bottle of Rioja or Malbec for you guys this weekend. You definitely deserve it. Sergio, always a pleasure. Thanks so much for watching. Thanks so much for listening. If you want to find out more about Rootstock, head to rootstock.io. You want to find out more about Rift technology, the scaling layer and ecosystem growth mechanism for Rootstock, go to rift.technology. My name's Daniel from Rootstock Labs, and looking forward to continuing our mission to make Bitcoin work for everyone. Thanks so much.
Thanks, everyone.
Bye.
Thank you.